Welcome to Diwakar Physics. In this video, we'll solve question number 8 to 14 from exercise 4a, class 9 physics. Okay, so I have already written question number 8. So let us solve this. In a hydraulic machine, a force of 2 Newton is applied on the piston of area of cross section 10 centimeters square. What force is obtained on its piston of area of cross section 100 centimeters square? Okay, so this is based on hydraulic machine. That means it is based on Pascal's law. So in Pascal's law, pressure in every part of the liquid is equal. So pressure at one place, F1 by A1, is equal to pressure at another place, that is F2 by A2. So pressure is equal. So F1 by A1 is pressure, F2 by A2 is also pressure. So pressure at every point in the liquid is constant. So F1 by A1 is equal to F2 by A2. So this formula you will use here, and you have to be careful about F1 is acting over A1. So whichever is the surface where force is acting, so you take them together. If area is A1, then F1 will be acting on this. Okay, so suppose, for example, here a force of 2 Newton is applied on the piston of area of this cross section. So if you take this as F1, then this is applied on the cross section, this one, so this will be A1. So F1, A1, like that. So don't mix them, that F1 is acting A2. No, F1, then A1. So this A2, then where is F2? What is F2? That is what I have to find. So this way you can easily use this formula and solve. So if I take this F1 2 Newton, then I have to take this as area 1, 10 centimeter. So because this force is acting over this area, F1, A1. So don't take this A2 like that. So this you have to maintain. Rest very simple. Now what force is obtained on the piston of area 100 centimeter? F2, you don't know. Then where is this F2 acting? Over this area. Then A2 must be 100 centimeters square. So this you have to maintain. Now simply you put the formula. So F1 by A1 is equal to F2 by A2. And use this pattern because it is easy to remember. Force is pressure is force by area. Pressure, force by area. Pressure are equal. Then F1 by A1, F2 by A2. Some books will tell you F1 by F2 is equal to F1 by F2 is equal to A1 by A2, like that. So there will be some confusion, you may make mistake, but this will give you the easy idea. Here also you have to write the formula of pressure, here also you have to write the formula of pressure. So learn this one. Okay, this pattern you can learn. But if you learn like this, F1 by F2 is equal to A1 by A2, so there is no harm. This also you can use, no problem. But I prefer this one, and students should also follow this, easy to remember. Okay, anyway, so 2 by 10, F2 by 100. Then you can cancel this. Then F2 equals to 20 Newton. So this way you can solve. And here you see I have not converted. I have taken force in Newton and area in centimeter square. So no problem. No need to convert this into meter square. But only thing you have to remember that both the areas should have same unit. Like here centimeter square, here also centimeter square. So if one is given in meter square, other is given in centimeter square, then you should change one of them. If both are given in same system, then no need to change, because we are dealing with the proportion. Okay, and here you say F2. Why I have written Newton? Because F1 is in Newton. If F1 is in dyne, then you should get F2 also in dyne. So that way you maintain. And writing unit is very important in physics. Okay. Now question number 9. What should be the ratio of area of cross section of master cylinder and wheel cylinder of a hydraulic brake, so that the force of 15 Newton can be obtained at each of its brake shoe by exerting a force of 0.5 Newton on the pedal? So this is the question. So here also this hydraulic brake based on Pascal's law. Okay, so what you have to find? First, what are given? You see F1, A1, F2, A2. You write like this. Then get these values from the question. So here force of 15 Newton can be obtained at each of its brake shoe. Okay, that is the wheel cylinder. So wheel cylinder will be there, and exerting force of 0.5 Newton on the pedal. So pedal is fitted near master cylinder. Okay, master cylinder. So here if I take master cylinder as this one A1, then what is the force acting on the master cylinder near the pedal? 0.5. And area 1 you don't know, because you have to find the ratio. Keep it like that. And 15 Newton can be obtained on each of its brake shoe. So brake shoe will be there near the wheel, so they will be near the wheel cylinder. So that means 15 Newton is obtained on the wheel cylinder. Okay, then you have to find this value, ratio. Now which formula you will use? F1 by A1 is equal to F2 by A2, and you have to find the ratio. So ratio of area of master cylinder and wheel cylinder. So first master cylinder is written in the question. You see ratio of master cylinder, area of master cylinder and wheel cylinder. So you also have to write master cylinder first. So which one is master cylinder? A1 or A2? Where is the force acting? So this you have to maintain. So as I told, 15 Newton is obtained on the brake shoe. So that means this is the wheel cylinder, and that means this is the master cylinder. Okay, this is the master cylinder. So F1 you have to, A1 by A2 you have to find. A1 by A2 you have to find. So A1 by A2 you have to find. What is this ratio? This is what required according to the question. Then put the values. 0.5 by A1, 15 by A2. Then cross multiply, and remember you have to find A1 by A2. Okay, then 15 A1 is equal to 0.5 A2, then A1 by A2. So I'll keep A1 here because I need A1 first. A2 I'll bring here, then 0.5 by 15. So 5 by 150. So A1 is to A2 is equal to 1:30. So this is the answer. Okay, so remember master cylinder is to be written first, A1, and what is that force applied on master cylinder? 0.5 near the pedal. So that's why F1 0.5, F2 is 50 Newton. So this is the answer. Now I will move to question number 10. The area pistons on a hydraulic machine are 5 cm square and 625 cm square. What force on the smaller piston will support a load of 1250 Newton on the larger piston? So same way I'll do F1, A1, F2, A2. Okay, so if I take this is 5 cm square, then this will be 625 cm square. Now what force on the smaller piston? So what force on the smaller piston? So you have to find the F1, force F1, because you have to find the force on smaller piston. Will support the load of 1250 Newton on the larger piston. That means on the larger piston, larger area, this force is acting. So it is very clear. So once you decide this, the next part is very simple. F1 by A1, F2 by A2. Then simply solve. So here, as I told, both area are in same unit, so no need to change. So 10 Newton is the answer, F1. So on the smaller piston, 10 Newton should be applied. Okay, we'll go to question number 11. The diameter of neck and bottom of a bottle are 2 cm and 10 cm respectively. The bottle is completely filled with oil. If the cork in the neck is pressed in with the force of 1.2 kgf, what force is exerted on the bottom of the bottle? So here we'll take the neck 2 cm. So diameter of the neck is 2 cm. Then actually the bottles are in the cylindrical form. Okay, like this. Suppose this is the bottle. So here the diameter is 2 cm, and these have circular cross section. So you have to use pi r square, formula of area pi r square, and so that means you need radius. Okay, so that's why you find r1. And what is the relation between radius and diameter? So radius is diameter by 2. So 2 cm by 2, so 1 cm. Then we have got area 1, pi r square, pi 1 square. So keep it pi only, because it will be cancelled. Okay, when you take A2, then it will be cancelled. So no need to use the value of pi, keep as pi only. Then what is F1? So we have got area 1, this area. So what is the force acting on this area? So that will be F1. If the cork in the neck is pressed in with the force of 1 point, see this force is applied on the neck only. Okay, on the cork in the neck. So that means this here only this force is applied. So this is F1, 1.2 kgf. Then we have got A1, F1. Now I have to get A2. So for that diameter 2 is given. Diameter of the bottom is given 10 centimeter. So D is 10 centimeter. Then R2 is equal to D2 by 2. So 10 by 2, 5 centimeter. Then area is equal to pi R2 square. This is area 2. Then pi 5 square. So 25 pi centimeter square. Then you have to find what force is exerted on the bottom. So this is the bottom area. So that means you need F2. Now same way we can use the formula for Pascal's law. What is the formula? F1 by A1 is equal to F2 by A2. So F1 is 1.2, A1 is pi, F2 is 25 pi, F2 is required, F2 is required, area 2 is 25 pi. So you can cancel pi, then F2 equals to 25 into 1.2. So that will give you 30 value. But what is the unit you say? We have used F1 as kgf. So here also kgf will come. So force on the bottom of the bottle is 30 kgf. Then which law we have used here? The second part of the question, name the principle used, Pascal's law. So you can just write Pascal's law. State the principle used, then you can write the statement of Pascal's law. Okay, so that way we solve. So here only difference is radius, diameter, radius are given or diameter is given. From there you have to get the area. So A1, A2 in terms of diameter. Okay, from diameter you can take radius, from radius use the formula because bottles have circular cross section. So this is the idea taken here. Now we'll move to question number 12. So here we can find force of 50 kgf is applied to the smaller piston of a machine. Find the force exerted on the larger piston if the diameter of the piston is 5 cm and 25 cm. So exactly like question number 11. Okay. So here F1 I can write 50 kgf. 50 kgf is already given. And where is it acting? Applied to the smaller piston. So smaller piston means this one. So this one will be D1. Then from here you find R1. Then you find A. So this is given diameter, so it must be circular. Pi R1 square. Then how much? Pi 5 by 2 square. So 25 by 4 pi centimeter square. This one. Now go to F2. What force is exerted? You have to find on the larger piston. So that means F2 is applied on the larger piston. So larger piston will have this one. So D2 25 centimeter. Then R1 25 by 2 centimeter. Then area 2, R2, pi R square. Then pi into 625 by 4 centimeter square. So 25 square, 625, and 2 square is 4. Now use the formula F1 by A1 is equal to F2 by A2. This formula you apply. So F1 from the question is 50. A1 is 25 pi by 4. F2 you don't know. A2 is pi into 625 by 4. So from here you can cancel pi, you can cancel 4, you can also cancel this 25. Then you have F2 equals to 50 into 25. 1250. So what was the unit in force? Force 1 is kgf. So your final answer will also come in kgf. So this is the answer, F2. So here also diameters are given, find the radius, find the area, then use the Pascal's law formula. Okay, then next we will go to question number 13. So question number 13 is like this: two cylinders fitted with pistons and A and B of area of cross section given, and these pistons or the cylinders are joined with tube and are completely filled with water. When a mass of 4 kg is placed on piston A, find the pressure on piston A. So you see, pressure on piston A. So for that, force is how much? 4 kgf, because this 4 kg is placed on the piston A. So due to this force or the weight of this 4 kg only, there will be pressure. So force is 4 kgf because mass is 4 kg. Area is how much? Area you can see here, 8 centimeter square. A 8, B 320 respectively. So area is 8 centimeter square. Then what is the pressure? Force by area. So 4 by 8. 4 kgf by 8 centimeter square. So the answer will be 0.5 kgf per centimeter square. This one. So you can write like this. If you want to convert this into meter square, you can convert it, no problem. You can write, express like this. Okay, so this is first part. Now second part, pressure on piston B. Now you know this piston A is connected with water to piston B. So according to Pascal's law, pressure exerted at any point is transmitted equally to every part of the liquid. So therefore, second part, pressure at B will also be 0.5 kgf per centimeter square, because pressure is transmitted equally. So same pressure using Pascal's law. And third part, thrust on piston B. So thrust is equal to, with the thrust formula, force is equal to pressure into area. Pressure of B, area of B, because they are asking for B. So what pressure is acting on B? Just now we have seen 0.5 kgf per centimeter square into area of B is how much? So area of B is given in the question 320 centimeter square. So we are using centimeter square, both sides same, so no need to convert. Then you multiply this, these two if you multiply, 0.5 half into 320, then you will get 160 and kgf. This will be cancelled, and finally, as you know, thrust is a force, so you will get 160 kgf. So this way we find. Okay, we'll go to the last question, question number 13. What force is applied on a piston of area of cross section 2 centimeter square to obtain a force of 150 Newton on the piston of area of cross section 12 centimeter square in a hydraulic machine? So this is also based on Pascal's law. So same way you can write F1, A1, F2, A2. So what is F1? What force is applied on the piston of area of cross section 2 centimeter? What force is applied on 2 centimeter square? So if you take this as A1, then this is unknown or question mark. then to obtain force of 150 Newton on the area of this, that means you will obtain F2 150 Newton over the area 12. So this must be 12. Now simply you apply the formula as you have done. So F1 by A1 is equal to F2 by A2. So F1 by A1, F2 by A2. You put the values, solve it, and you get the answer 25 Newton. Thank you for watching my video.